On January the 21st, 2021, the Raspberry Pi Foundation launched a brand new product, the Raspberry Pi PICO, and it just so happens we finally managed to get hold of one here on the channel. Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello, how you doing, and welcome back to Wi-Fi Sheep right here on YouTube with me, Tom, and a special warm welcome to all the brand new subscribers that have joined us since our last video, which is of course where we first talked about the announcement about the Raspberry Pi PECO. Well, they finally managed to get one to me. Well, I say that, Pi Hut finally managed to get one to me. We've had terrible weather right here in central Shropshire the past few days, so through the thick ice and snow, we've managed to carry on. I've got hold of one, so I thought, what better to do than to just get down to it, see if we can get it wired up and see what it can do. So let's take a look. And here we are. This is the Raspberry Pi PECO. So a lot of people have been associating this new board with the Raspberry Pi Zero. This is a slightly later Raspberry Pi Zero W. And as you can see, the Zero W is a small and extremely low cost board. But you can see how small the PECO is compared to the Zero. And there's been some confusion with some people thinking that this is a brand new Raspberry Pi. It's not in the sense of what is a Raspberry Pi. This is a microcontroller. So is it a computer? Yes, it's a computer. Is it a computer in the same sense of a self-contained system like a Raspberry Pi? No. So if we take Raspberry Pi, for example, we'll just move that out of the way. So we've got Zero, we've got, this is a Model 3B Plus. I've got my original Model B. Remember those? The original Raspberry Pi from 2012. Trying to think, where's my... Now, all of these are actually standalone computers. So most of them run off an SD card. You put an SD card in, it has an operating system, and you plug a keyboard, a mouse in, you've got a network connection in most cases, and then you've got some sort of audio and video out, and you power this up and it will work as a complete standalone. I use the word PC, I don't mean PC as in the x86 Windows type things you would associate as being PC, but as personal computers, all these boards are able to behave and act as independents. That's not the case with the Raspberry Pi PECO. So the PECO is what we would call a microcontroller. Other examples of microcontrollers, for example, could be the Arduino Uno. This is a proper Uno board. I have a Uno clone, which is nigh on identical, but not quite the same. I have, this is a clone Arduino Nano board. The Nano is probably the nearer thing. It's kind of a bit smaller, but it's kind of similar size. Here's a standalone Atmega 40-pin DIP. This is a Atmega 328P. We have other higher-end controller boards. So this is a ESP32. And dare I bring it in, but I will, even the BBC Microbit is a microcontroller. And now the Raspberry Pi PECO falls into the category of being very similar to the rest of these boards. So as a standalone microcontroller, the Raspberry Pi PECO is capable of performing certain set functions and logic. So for example, if you needed a way of building, I don't know, a robot or something that needed some kind of independent computing logic, but didn't need a full-blown Raspberry Pi, then something like this sort of microcontroller would come in very, very handy. You could program it a set of instructions, easily access many multiple GPIO pins to connect up to other components, motors, diodes, that kind of thing. And you can actually put computing logic very cheaply into an additional circuit or product that you're doing. And that's what makes these things fantastic. In most cases, the code is written on another computer. So, for example, a Raspberry Pi would be needed to program this. It can't do anything on its own. And then you'd upload code via the USB port here on the end. Or you can actually, believe it or not, interface through some of the GPIOs. And then in the case of the Pico, you actually have this little button. Now, most of those, it's a reset. On this, it isn't. It's a mode switching button. But that's fundamentally what a microcontroller is. So is it a full-blown computer? Well, yes, it is a computer. It's a question that will be going on for debate for ages probably, but yes, I believe it is actually a computer. The specs on it are actually very, very good. So, for example, it has a custom CPU. For the very first time, the Pi Foundation have done a custom ARM CPU. So this little Raspberry chip here, this is a twin-core or dual-core ARM Cortex-M0. So it is a 32-bit ARM processor, not too dissimilar to the chip actually seen here on the Raspberry Pi Zero. It's clocked at 133 megahertz. Now, that is quite slow in terms of computing for nowadays. You think the Zero runs at 1000 megahertz, but for a microcontroller, that's actually pretty fast. If we bring in, let's say, something like the Arduino Nano, these things run at a clock speed of 16 megahertz. So this is considerably faster. It has 264K of working RAM. Again, remember it's a microcontroller, not a full-blown computer board. That's plenty. Our Nano here has a mere 2K of RAM on board. So again, the specifications are actually quite good. It has 4 megabytes of onboard storage. The difference between these two is there's no EEPROM. So there's no way of being able to save data generated by a program. So you can upload to it, that's not a problem. But then if the code you upload when it needs to try and save some data, it can't. Unlike the Nano, which does actually have a way of saving onto a flash chip. You can add flash memory to this device, but it has to be as a separate circuit and manually wired in. Now, at time of recording, which is January 2020, the Raspberry Pi PECO comes shipped just like this with no header. Very similar to actually what the Zero is, with no header. Which means that in order to do anything with this, to connect it up to anything other than the USB, you are going to need to add some headers. Now, you don't need headers as such. If you want to solder wires directly to these pinholes, you can do that. That's perfectly valid. But I think what we'll need to do is add a header. So I had a dig around in my electronics box and I found a piece of header which was actually perfectly spaced and cut to the correct size. And I have another longer piece here which I think will cut down to the correct size. You're usually going to buy these like this, unless you buy the actual proper little kits that some of the manufacturers do that allow you to populate your boards. So in this case, we just need to take a pair of snips, something like this. Make sure we actually cut this the right size. And there we go. So we've now got two pieces that we can attach. Now I was thinking about the best way to do this because soldering on is actually quite tricky because you need to make sure these pins are straight and they do have a tendency to rock. Also, I'm very aware that some of you won't want to solder or can't solder. Right, so this next bit I was actually going to cut out the video, but I've decided to leave it in. It's completely unofficial and not particularly going to work that well, but I've figured out a way that you could actually use the serrated edge of the Pi board to connect it to GPIO pins without needing to solder anything. Take a look. I've got a solderless breadboard and I'm going to put the first row in with the longer pins down. I need to space these, I think, a little bit wider than the Pico board. Make sure those are down. So they're lined up correct. And we've got the divide of the breadboard in the middle. So electrically these pins are isolated from these pins. There's no through connection. The Pico board has these little perforated edges. So you've got the main holes and then you've got these sort of notches on the outside of the board. And this actually allows you, without the need to solder, to actually make a connection. So if you've got your pins correctly spaced, you should find, although it will be a very tight fit, there we go, that your Raspberry Pi Pico board will actually fit in between, and these notches will interlink with the top of the pin header. That will make a connection. However, you have to understand you're only friction fitted. So how good that connection is going to be will rely on how clean all the contacts are, and it's going to be a little bit intermittent and flaky. If you can't solder, and there's a number of reasons, people either don't want to, they don't feel confident with soldering, or they're not allowed to solder. A lot of schools nowadays cite health and safety as reasons for not soldering. That is a way of connecting to a breadboard without needing to solder, and of course it means you can lift your board back out as is. However, I actually do want to solder, so what I'm going to do is I'm going to take one set of pins up, and just move it one up nearer to each other. Now hopefully we can now loop these through the holes. There we go, and that will also stay nice and square and straight. Quick disclaimer, whenever I do soldering on the channel, which is not that often, I normally get a barrage of complaints and people telling me I can't solder or I'm doing it wrong. What I will say is this is my method and it works for me, so I'm going to show you what I do. I have improved the method thanks to some of the more positive and constructive comments over the years here on Wi-Fi Sheep. But again, if you know better, then all I can say is, well, good for you. What you need to make sure you have is some decent electrical solder. That's the thin stuff. Don't use the thick plumbing solder you get out of DIY stores. It's not suitable. You need this sort of thin core solder. It doesn't have to be lead. This isn't lead. This is I think it's a pewter alloy or whatever, so it's not lead. There's no poisonous chemicals or anything here. And you will need some flux. I use this stuff, which is Topnic RF800. This is specially designed for printed circuit boards. No clean, because it's actually alcohol based, which means you open it up, and you do need to do this in a well ventilated space because this stuff does give off quite a bit of fumes. It's flammable and obviously needs to be treated with care, so it won't be suitable for all environments. But you get a little brush like that, and then you just literally paint on the flux just on top of the pins. So you put the flux on. I'm going to take just a bit of solder, and again, it's very tricky to do this when you can't see what you're doing. But you see, it's really, really simple, really quick. It's not a big deal at all. Okay, I'm just going to go over these two because I can see I haven't put enough solder on, so let's just get these. Okay, so I've literally just gone back over. I haven't added any more solder, I've just heated up just to make sure that the flow on the connection is good. And yeah, that's looking great. So we'll just let that cool down now. And because we use the alcohol-based flux, all that flux will evaporate, what hasn't done already, and just leave us with a really good connection. So we just need to make sure that we haven't got any of these pins bridged with solder. We don't want to create a short. It's all looking really good, actually. If you're nervous about soldering your first time, it is really that simple. One little thing of note, which I will show you comparing it to a Nano, is the Nano has its pinouts printed. Actually, I think most, if not all, Arduinos actually have their pinouts on the silk screen on the top of the board. The Raspberry Pi PECO does not. This is extremely annoying. The pinouts are actually underneath the board. So you could argue that maybe you should use it upside down. The only mistake of using the board upside down is you then can't access the button if you need it. And I don't know how well that works, how hot the chip gets, because obviously I've not powered one up yet. Also, these pins here on the end, you can populate them, but if you populate them with pins going downwards, what will happen with the breadboard is that if you connect in and these two pins, let's say, meet here and here, they will actually short. So to get around that, as you can see here with the Nano, they've actually put another jumper going upwards, pointing up. So I don't need these pins at the moment, so we won't populate them. Also, because the Raspberry Pi Pico has screw holes, it's one of these boards you can actually screw and mount into things, they've had to move, let me show you that, some of the jumper labels don't correspond to the correct pin. Okay, so we've got our now soldered Raspberry Pi Pico. I've just placed it onto a breadboard. You don't need to put it on a breadboard for this particular bit, but I've just decided it's easier to handle it. I don't have to touch the board, especially when it's live. So we've got my adapted mini to micro USB to standard USB-A. So we'll plug this side into here, and we'll plug this into my MacBook. Now it does say to hold down this little white button, which is labelled as boot filing system. So we'll hold that down as we plug in. Now, as you can see here, it's come up as a file directory on a Mac, and it would do the same for a PC, Linux, or even on a Raspberry Pi system. Now, if we head over to the Getting Started guide on the Raspberry Pi website, I'll put a link to this in the description of this video, and it talks about the specifications. It gives you the pinout, which is quite useful. We can also click here to Getting Started with MicroPython, and it suggests to install MicroPython you need to download this particular file, which we'll do now. Okay, so I've downloaded the file, here it is, and to install we simply need to drag and drop, copy and paste. We'll install the file, and then as you can see, the Raspberry Pi Pico has actually ejected itself. The Mac isn't very happy about that because it just said you just pulled a mounted drive out, but it has actually ejected itself, and it now won't read back into the system again until we actually hold down the button and reinsert the USB drive. So that's fine. So we've now put a MicroPython kernel onto the board. Going back to the website, so it suggests using a IDE interpreter called Phony, which I have already pre-installed. Get it for Mac, Windows, and on Linux. What you need to do is make sure, first of all, it'll ask which mode you want to run in, Raspberry Pi or standard. Make sure you select the standard mode, not the Raspberry Pi mode. From the Run menu, you can select Interpreter, and then you'll need to select the Raspberry Pi PECO build, which is here. It also supports BBC Microbit, by the way. So if you have one of those boards, as you can see, it supports a fair few things. So we'll say, obviously Raspberry Pi PECO. Then ask you what port it's on. So the Mac, it's here. And we'll say OK. And you can see it brings up the MicroPython shell down here. So we can ask, for example, help. And it runs just like a simple Python shell. So I could say x equals 1, ask it to print x, comes back as 1. And yeah, so we're basically up and running. Now I did try to see if I could actually wire up the Raspberry Pi Pico to an ATmega 328, acting as a video terminal chip, as used on our Tiny Basic Computers project we've been doing here on Wi-Fi Sheep. Now, despite moving the baud rate to match the TX, that's the serial output of the Raspberry Pi Pico, I wasn't able to get this to work, unfortunately. But, you know, it's early days, and not all the new documentation is actually out there at the moment for the RP2040, which is the new custom ARM chip that the Raspberry Pi Pico actually uses. So it's early days, this bit didn't work, but I'm not disheartened, and we can carry on. So in conclusion, well, we're still waiting for some drivers to come through to use this brand new Raspberry Pi architecture. That's the RP2040 as seen on the Raspberry Pi PICO board. I particularly am looking forward to when it's announced and released for use with the Arduino IDE environment, which is my preferred environment for doing sort of microcontroller based work. But overall, yeah, it's a strong product. It's looking a very promising product, but we are in early days. So I think it's very much the case of watch this space. We are obviously hoping that we can incorporate this new chip into our Tiny Basic Computers project right here on Wi-Fi Sheet. If you want to find out more about that project and where we're going with it in the future, do check out the playlist, which will be on the screen up here somewhere. Or you can join our Facebook group, which is Tiny Basic Computers, and can be found at facebook.com/groups/WFS Tiny Basic. Well, I hope this has been an interesting video for you. Once again, thank you so much for your company. Don't forget to like and subscribe, and I will see you real soon right here on the channel. Look after yourselves, and until next time, bye for now.